All right. Maybe got slides. Nice. All right. Thanks everyone for coming to this session. I'm going to talk about Kunekt's private collaboration protocol. I will try to unpack what all this means. Private real-time collaboration on Kusama Jam is quite a mouthful, but we'll go step by step. First, we'll talk about the protocol Kunekt, what it actually does, what it means, the engine that powers the operating system where this protocol will be running on. And last but not least, the framework is the actual way people will develop applications on top of this protocol. It's actually our first priority, like most of the time. Maybe the way to go is to start with the protocol. The way to go is to build all the stuff from the ground up and maybe worry about developer experience and users later, something that I don't think has worked very well for us. But okay, luckily we will see, maybe the idea will be compelling on why it makes sense to start this way. There's some analogy here, like Kunekt, a protocol, could be compared to, for example, the parachains protocol on Jam. Parachains are going to be services. Kunekt is going to be just another service. The operating system was, the analogous could be core VM. Some people might have heard of that. Is what abstracts the underlying technology. And smart contracts of frame, that would be the analogous for RIT. A little bit about me. Been doing Rust development for 10 years or something like that, like a couple of decades breaking stuff. Very passionate about Kusama, kind of sometimes wondering why people are not paying too much attention to Kusama, as it's the most decentralized network with a ton of, like, all the good stuff first lands there. It's super cheap. It has tons of potential. So hopefully I can convince you a bit that it might make sense to use Kusama more. Also, a bit of extra context. I'm the founder of Virto. Virto is like we want to be the partner of entrepreneurs trying to build real-world applications, not only in the Polkadot ecosystem, but in general, trying to be this friend, the Web3 CTO as a service. So all the entrepreneurs that kind of know about Web3 or heard about it, but don't know how to approach it, we provide a lot of tools, a lot of components that are already, like, using technologies people already know. Like, organizations don't need a specialized knowledge or developers that are only Web3. Like, they can use technologies that they already know. And so, yeah, we want to provide this toolkit, like, and give them basically almost everything they need to build entire infrastructure and use us as their backend. But I say almost because real world, like actual products, they are not just on-chain smart contracts. They're a bit more involved than that. Like, often what people do is to have some on-chain component, and the rest is delegated to some centralized infrastructure, like normal database, where private data or sensible data that shouldn't be on-chain is stored there. But then, is it really a decentralized application? Our workaround for now has been to provide them with a federated server, some piece of software they deploy in their own infrastructure. Because if we deploy this infrastructure for them, then it also doesn't make too much sense if we end up just hosting everybody's code, not so decentralized anymore. So yeah, in an extra bit of context on why we are excited about Jam, especially Kusama Jam, is with so for those who don't know, recently the KSM holders voted and said, like, we want a fast, light, independent Kusama Jam instance. What does that mean? Another option was for Kusama maybe in the future joining the same Jam instance as Polkadot. But by being independent, it can, like Kusama can keep this experimental, fast-moving spirit, and it will be a reduced chain, like very different from the full Jam deployment. It will have 1 second block production, and I think this brings so many possibilities. It's a very fast moving chain that will be very suitable for protocols like Kunekt for real-time applications. So let's unpack a bit like what real-time collaboration, private collaboration on Jam means and what does this enable. So yeah, let's first also repeat, no, organizations need more than just what we usually deploy on-chain. They need a way to communicate, to collaborate, to store encrypted data, to have great user experience. Often, I don't know, I think we are very conforming with little lately. Just because somebody can use the blockchain with their phone, then we are happy. But users nowadays, they expect a lot more from applications. They want very enjoyable experiences. For example, yeah, like people collaborating in Google Docs. Many people are looking at the same document on Notion. You can collaborate with a lot of people dynamically. Everybody is is like expecting a lot from these apps nowadays. And this is kind of the problem that Kunekt tries to solve, like to use Jam to host, like this infrastructure I was saying that we were telling organizations to host on their own. I think now we can pack everything in one place, so people don't need to deploy specialized infrastructure. They can just come and have the entire backend, all their stack deployed on Jam and ready to develop the most compelling user experiences. Also worth noting that Kunekt is not a protocol that will compete with parachains. Like, for example, here are some different Jam cores. Like, one core will be running a parachain service, like Cravo, our parachain. And another core can be running the Kunekt protocol, where there's a network of peer-to-peer users that are all editing together the same documents, smart documents that I call, and they're sending each other these updates and synchronizing with Jam, and that in turn can trigger transactions that go and call some code, like a smart contract or something on chain. So a little bit deeper, but without going too deep into Kunekt's overview, it's a bit like Git, it's a bit like Matrix, like the first federated server that we were giving to our organizations. It was something built on top of Matrix because it provides encrypted communications. It's a way for people to remain in control of the data and still be able to communicate, interact with other organizations. They will keep data not only for chatting, but for any kind of application could be built on top of Matrix. But now this will be like a mix of this and a concept that that makes it look like a version control system, like Git. These CRDTs. CRDTs stands for conflict-free replicated data types. It's the way most real-time applications work nowadays. It's a way to store data or to represent data in a way that different people can be making changes. For example, here Alice is doing a change, then another change. This goes like a bit like these commits in Git. No? Another user can be touching the same document, the same data. And changes go, like people are touching the same stuff, but eventually people want to like check each other's work and like say, hey, I think we edited the same thing, now we have a conflict. But CRDTs, what they guarantee is that you will have this eventual consistency. So eventual consistency means that we can all be touching the same stuff. I update something, I send you the update, like say, hey, I did this change. And eventually we all can automatically merge our changes in a conflict-free way. And then we can all be happy and agree on the state of the document we are working on. Also, I was saying a bit about like Matrix. Matrix, the way it encrypts, does end-to-end encryption of messages is with this group ratchet technology. It allows this forward secrecy where new users that join a conversation, they cannot decrypt past messages, but so only future messages. And the idea is that we will allow people like opening a document, they will be sending each other updates. These updates will be encrypted using this technology. So like each of these commits or changes, there will be like encrypted changes that will be sent to Jam. So whenever I want to log in later, if there's no other peer connected, I can still pull these changes from Jam. And in Jam, there's like a non-trusted peer. Like you could say Jam as a participant of this document, like has the rights to open it, but it's actually not seeing the changes because these changes are encrypted. It would be like, that's the whole point of this protocol, to have encrypted collaboration. But so what's the point of having a Jam getting these updates, but it cannot do anything with them? The idea is that like sometimes some updates don't need to be private. Sometimes it can be a proof, a zero-knowledge proof, or some kind of order like saying, I don't know, hey, we all agree, like all the participants editing this document, we all said that we would like you, peer, on Jam, like this thing, the code running on Jam. Hey, can you represent us and send some transaction on chain, trigger some smart contract? Like, I don't know, imagine you are drawing something and the moment you lift your finger, all this stuff is real time, so immediately the current state of your drawing became some NFT that was sold in some market on chain, triggering some smart contract. So far, so good, I hope. So now let's talk a bit about the engine. No, this protocol could be developed in different ways on top of different technology. I chose to create a new operating system. BOSS is literally an operating system. It's built using embedded asynchronous runtime in Rust. And it provides some way for tasks for these programs to collaborate with each other in a cooperative way, it's called. These programs will be written using WebAssembly, WASI, more concretely. WASI is like a way to do WebAssembly outside of the web, like program regular applications that are compiled to WebAssembly. But this will be, in the case of Jam, this will be compiled ahead of time to PVM. And it provides other facilities like abstraction for the file system, even some scripting. But most importantly, I think, is that it runs everywhere. So why I think, like in the server, in the web, in hardware, and of course in Jam. But why this is important? Now comes a bit of the strategy. I think for these kind of protocols to succeed, including what we're building in the Polkadot ecosystem, we need to meet our users where they are. We cannot just hope they're going to come and use the stuff we're building. I think we need to give them, to developers, for example, a tool they can use today for whatever need they have today, like a plugin system they can hook into their game engine, or, I don't know, AI, MCP server. Like, I just want to create something that has good value today to people. For example, we say like, oh, we are doing Rust. Rust has a lot of developers, and therefore Rust developers are going to come and develop in our ecosystem. I don't think so. Most developers, you go on Reddit and mention the word blockchain, you will be even banned, or I don't know. Like, people really hate blockchain. Like, they got really traumatized, even, including organizations. Like, they don't want to do much with blockchain crypto. You mentioned that, and it's a bit, yeah, like, sounds always like scam. I don't know. It's really hard to convince people that this technology can really benefit them. But if you give them stuff like a backend that they can already deploy, that's going to be fast, that's going to be easy, they can install plugins easily, I think that has a lot of value of merit. Voss wants to be a very global runtime that can be used for many things. Because the strategy here is kind of be sneaky, no? Like, we give them something they can use today, something nice, and maybe sometime later, when Jam is ready, with them, by the way, the stuff you created, you can now deploy that on this decentralized public infrastructure that's just going to make your life easier because it's going to be cheaper, it's going to be more scalable, and so on. All right. And last but not least, we have the operating system, but now we need to develop applications on top of it. Instead of coming up with a new fancy language or some very different way to develop applications. Since all this stuff, like, I'm a big fan of Rust, and I think people, like, the easiest, more cleanest way and nicest way to write Rust application, like code, I think is Ink. Like, Ink is pretty great. So I modeled read following the same structure that Ink has. If you didn't spot it, I just put this async word there just to make a difference, but it's actually optional. The idea is that it will look very much like Ink. It will be good not only like to maybe as a way to onboard people into discovering later Ink and maybe know that they can do something on chain as well, but also because Ink is great and it's simple. No? Ink is, well, read will be async. It must be familiar. You can take these programs and run them standalone, like no need for like Voss or blockchain or anything. You can create a simple program, a simple backend, just deploy it. It will be good. Has great developer experience. It compiles fast. Like, it's built on top of technology like WebAssembly, WASI, that has a lot of tooling, a lot of stuff that you can just write a regular main application that like what regular developers are used to. No need to acquire specialized knowledge. And yeah, abstracts away like storage, how data is stored, or how messages comes and are dispatched, and so on. Also, to be developed is PVM friendly. The idea is that these WASM programs will be transpiled to PVM so they can run on Jam natively. All right, I will, if I can, I will quickly switch to demo, but I promise it's going to be...
We have just a minute or so left, and then we have our break. How long is your demo?
1 minute.
OK, great. Perfect.
All right. I will just... where is the escape? Then I will do this. Or I guess I will owe you the demo. Better not mess up with schedule. All right, I'll just tell you what you should imagine that was going on, because it was a simple demo. I was just going to show you. There is a read program. You hit build, and it will compile in 3 seconds or something like that from scratch. Like, as I was saying at the beginning, developer experience is going to be very important. For example, compile times and the way you interact with this code. It needs to be very compelling, and the code was just going to show you how in 3 seconds the whole thing gets built from scratch and you can run some program. I will share maybe in some other opportunity, the links to our repos and the current state of this development. And that's pretty much it, I guess. Oh, it actually showed up, no? So it was just gonna do this. And if I can hit enter, then we are good, golden. That's building from scratch, and in 3 seconds, you just got something. No, that's a program more or less. Should look very much like ink. That's it for now. I will go back here and say thank you.
Thank you. Does somebody have a question just really, really fast for Daniel? Okay, amazing. I just have a quick question. Why do developers hate Rust so much?
Developers love Rust.
They love Rust.
Yeah.
Amazing. Thank you so much, Daniel. We really appreciate you. Are you going to be around later for people to come up and see you and ask questions?
Chat.
Amazing. Yeah, if you guys are still here, definitely come up and talk to Daniel. We are going to take a break. So thank you so much. Give a big round of applause for Daniel. Thank you.